Welcome to the first lecture on vectors. Now, we have to first be able to distinguish between vectors and scalar quantities to be able to appreciate the concept of vectors. Now, a vector quantity is a quantity which has both magnitude and a specific direction in space, and a scalar is a quantity that has a magnitude but no specific direction in space, or in other words, a scalar quantity is one that is fully defined by magnitude alone. So now in vectors, there is a specific direction, right? And in scalars or scalar quantities, no specific direction, right? Hope that's clear. Now, having the triangle ABC, sorry, this not straight. Let's try again. Okay, so this is better. Let's label this A, B, C, right? Now, taking the length of the side AC to be 2 centimeters and the length of the side BC to be 2 centimeters. Now, we can be asked a simple question to find the length of AB, right? Now, to find the length of AB, one logical way is to just add 2 to the 2 centimeters to get 4 centimeters. But in vectors, it doesn't actually work that way. And why is this so? This is because this is 2 centimeters in this direction, right? And this is also 2 centimeters in this direction. Therefore, each of them has a magnitude and is relatable to a definite direction in space. And this is why this is called a vector, right? So if we were to be having this line AC to be in this direction, it will probably not have the value to be 2 centimeters. This is because this 2 centimeters is not only affected by its magnitude, but also this is affected by the direction as well. And that is why we call this a vector. Wait, this is not called actually a vector because we've actually made a big mistake. As we learned in our definition, a vector has a magnitude, as we have over here, and also a specified direction. So if you do this in your exams, you might probably be getting the full marks. You will definitely be getting the full marks. But if you leave it without the arrows, you can't be penalized. Okay. Now, let's look at various forms in which vectors are represented. So now, I'm sure you've read a number of books, and there are so many ways to represent vectors. Okay, now vectors can be represented. So, for instance, we can represent this length AC by A, and this A has been deepened. So you'll be seeing this in most of the books you'll be reading. You can also write vectors as A with this sign under it. Okay, hope that's clear. So if in any part of the lesson or in your textbooks you come across um these symbols, you should know that they both represent vectors, right? They both represent vectors. Now, A vector has a specific direction and also a specific magnitude, right? Now, having these two vectors, and let's call this vector A, and let's have another vector, and let's call this vector also, let's say B. Now, what can we tell from these two vectors? Even though they are not actually drawn to scale because my line is not straight, let's assume this is actually straight. Okay, now they have the same direction and one is longer than one. B is actually longer than A. This means that the magnitude of B is greater than the magnitude of A. Therefore, the length of the vector actually tells its value. So I didn't actually draw this diagram in using a scale, but as a matter of fact, this should actually be somewhere of 4 centimeters, not 2 centimeters, because this side is actually longer than this side. Okay, as I said earlier, this is not drawn to scale. Now, let's get back to our definition of vectors. So this can have a value of 2 centimeters or meters or even feet, and this can also have the value of 4 centimeters, right? So that this is the direction and the length represents the magnitude of the vector. Thank you very much for watching the video. This is just an introduction to vectors. Please watch the other videos and remember to subscribe. Thank you very much. This is Teach Me Math.